Now we are going to see one of the most important inequalities in all of mathematics, namely the triangle inequality. Theorem: for all real numbers x and y, we have the absolute value of x plus y is smaller or equal to the absolute value of x plus the absolute value of y. In other words, the absolute value of sum of two real numbers is smaller or up to equal to the sum of their absolute values. For example, if we take x equals 2, y equals 3, then in the left-hand side we have the absolute value of 2 plus 3, and in the right-hand side we have the sum of their absolute values, which is equal. So the statement is clearly true. If x is 2 and y is -7, then the left-hand side is the absolute value of the sum, which is -5. And in the right-hand side, we have absolute value of 2 plus the absolute value of -7. And clearly, this number is 5, which is smaller or equal to 2 plus 7. In order to prove this inequality for all real numbers, let's consider the proof here. Let x plus y is a non-negative real number. Then by definition of the absolute value and the theorem 5.1.1 statement E, we have the absolute value of x plus y must be equal to x plus y, since absolute value of a non-negative real number is the number itself. But then x is smaller than absolute value of x and y is smaller than the absolute value of y, following the theorem 5.1.1 statement E. Similarly, if x plus y is a negative real number, then by definition of absolute value and the same theorem 5.1.1 statement E, we have the absolute value of x plus y equals the negative of the number x plus y, which can be written as negative x plus negative y. But negative x is smaller than its absolute value, namely absolute value of negative x. But we also proved that the absolute value of negative x equals to the absolute value of x. So this number here must be smaller than absolute value of x, and this number here must be smaller than this number here. So the sum in the left-hand side must be smaller than the sum in the right-hand side. So we proved that this guy is smaller than this number. This concludes the proof. Corollary: for all x, y, and z real numbers, we have the absolute value of x minus y is smaller or equal to the absolute value of x minus z plus the absolute value of z minus y. This inequality can also be written as the absolute value of x minus y is smaller or equal to the absolute value of x minus z plus the absolute value of y minus z. b. The absolute value of x minus absolute value of y is smaller or equal to the absolute value of x minus y. Let's see the proof of the corollary A. Since x minus y can be written as x minus z plus z minus y, then we can apply the triangle inequality to the quantity here, absolute value of x minus y, which is equals to absolute value of x minus z plus z minus y. Now we can consider the first two terms here is A, and the second two terms are B. And this is by the triangle inequality would be smaller or equal to the absolute value of A, which is the absolute value of x minus z plus the absolute value of B, namely the absolute value of z minus y. The corollary B is an extremely important inequality with frequent applications in our course. Please try to prove it. Let's have a little hints. We can write x as x minus y plus y. Then by the triangle inequality, we have the absolute value of x equals the absolute value of x minus y plus y, which is smaller or equal to the absolute value of x minus y plus the absolute value of y. Then we can transpose this term to the left hand side to obtain this inequality. Now you can try to complete the proof.